Generals, distinguished ladies and gentlemen. With the last panel on technology and strategy, with this panel, I would like to actually start with 4 ideas. Here, about half a year ago, we had a memorial, an event for 300 years engineer academy. What we saw at this event was what achievements were made on the technology side. It's the insight that we develop from this, how manifold this area, strategy, and technology is, was also shown by the publication in this connection that showed how many things were done here. On the other hand, it also showed, and this is the reason why we are here at this strategy conference and are talking about it, that there are common features that are missing, because with the heavy specialization of the various offers in education, the basics that actually were described as universitas, the universal side of basics, are totally missing. And I have, with great pleasure, noticed that there are first attempts being made to actually offer a cluster event together with the University of Life Sciences, the Diplomatic Academy, and the Austrian National Defense Academy to prepare something together in order to promote the new thinking that is required. And I've heard that this lecture is a success and well accepted. This means we should try to do more in this. The second point is that we are living in times with the peace movements and with the 68 movement where there has been a critical attitude toward technology on the part of large parts of the population, and that this has had reverberation in politics. I don't need to convince you here how important technology and engineering are for our modern society, and our society as we live today would be unthinkable without technology. The rise of Europe in the 18th and 19th century was due to technology and engineering. What was maybe exaggerated in some of the totalitarian states, the pendulum has now actually gone in the opposite direction in some countries, and we have to try to find the golden middle again. And Professor Schädelmeier in Salzburg actually talked about this already in the 60s. The third point is the position of technology in the Austrian Federal Army. Here too I was surprised and quite enthusiastic how manifold the applications are and what achievements the Federal Army has made over the years. The introduction and rather integration of leadership principles and into military strategy on a national and international level have reflected this. I see some deficits, however, and this is one of the reasons why this strategy conference is being held at a facility dedicated to strategy, because the insight has taken ground that something needs to be done in the usual Austrian manner. This will take a little time, but we should not give up hope. And the fourth idea that I would like to include here, something that made me truly think. Last year, the Chinese People's Congress defined a new program, an economic plan, decided on it. And this was not a 3-year plan or 5-year plan or a 10-year plan. It was a 30-year plan. So this is a generational plan. Now this gets me to the point. Under the security heading, they did not list Air Force, Navy, missiles, but they listed intellectual warfare. And this makes us think. And this is another motivation, another reason why we here in Austria and Vienna have organized again this strategy conference. And I'd like to thank the organizers for the first time in 100 years, to 1817 to 2017, has taken on this topic of 300 years achievements of engineers in the Austrian army. There was a unity. It was more integrated into society, and there was more consensus regarding these basic questions. So much for the introduction. We have to stick to our time frame, and I would like to ask the first speaker, Oberst Richter, to start with his talk. Colonel Ritter is a graduate of the military academy. If I remember correctly, he graduated a while ago. In 94, this was the time when I started teaching, when I finished teaching. He actually joined the military. 10 Grenadier, was a teacher as well and was studying at the same time. And now he's working in the Federal Ministry of Defense and dealing with military strategy. And we're looking forward to your contribution. Ladies and gentlemen, thank you for the kind introduction. I'm working in the Federal Ministry of Defense on security policy, and I'm in charge of analysis, future analysis. And for some years now, I have been working on the use of alternative futures, the use of scenarios, and to develop scenario-based strategies. It's always been important to look into the future, especially politicians at all times wanted to know about the future so that they could shape their actions in such a way that it was favorable for them. If we go back to the Oracle of Delphi, Nostradamus, and Gamma Rogers in the present times, people always wanted to have information about the futures. The future is a dimension that cannot be fathomed, and there is no scientific method that allows us to actually forecast the future precisely. All our future thoughts are images that are constructivist and are based on empirical thoughts and statistical models. One of the most important management tasks is, however, to shape the future, and therefore politicians and decision makers and strategic planners at all levels need to have an idea about the future. In order to shape the actions and make it fit for the future, where are the challenges of strategic long-term planning? On the one hand, it's the planning of with insecurity and the complexity of the fields that we move in. Shoemaker wrote in his book, Profiting from Uncertainty, that it is not only the extent of the uncertainty that is a challenge for strategic planners, but also the ever-changing nature of it. So as we can see here, there's a broad range of uncertainties and unpredictability, from a future that's relatively stable to one with total uncertainty and chaos. In between the two extremes, we have where you can plan the future, and the other side where you can't plan for anything at all. There is two further situations, degrees of certainty, rather uncertainty, and there are, of course, different ways to describe that. Two parties correlate, a law is decided on, cooperate, a law is decided on, or this is not the case. But organizations, companies, such as the armed forces as well, have to act in situations where there is a large number of different multiple options. And the third level of uncertainty that you might also find a future space that needs to be thought through. Basically, we can say that the most of the operational and business decisions happen in level 1. Long-term planning is a little different. Here we have very often the mistake that's being made that on the one hand uncertainty is underestimated, and with people work with an exact prognosis wherever it comes from, or uncertainty is increased, and this actually then leads to an unpredictable. The truth usually with most strategics is somewhere in the middle. I've tried to show this here. In this middle ground, companies need to think about the future without being able to forecast it. They have to deal with thinkable options for the futures in order to navigate in between security and the helplessness on the other side, where there are totally unclear situation, all ranging all the way to chaos. The room in the middle is called a space of limited insecurities. Now, how do we get information about the future? We need experts, we need forecasts. I have a few listed here. Well, Mark has space for 5 computers. This was IBM CEO in 1943. Television, after the first 6 months, is going to fail. People will not want to stare into a box. Century Fox Boss in 1946, and now my favorite forecast, the worldwide demand for vehicles will not surpass the 1 million mark because we will not have the chauffeurs. This was done in a very early study by Mercedes, by Daimler in 1901. Because one looked only at one parameter, how many drivers do we have, and how can this be extrapolated into the future? And other factors were not taken into account. The belief of people in technology and into the future in changes. This was not included in this assessment. Who are the experts that we believe here a party was ending? One day later, after this statement, Mr. Quirup, the CEO of the Economic Advisors, said that this was not the case. Although in 2008 we had the first messengers on the horizon forecasting the crisis, there were different forecasts, and so we like to use trend extrapolations. When Elvis Presley in 77 died, there were worldwide 37 imitators. 2015, there were 40,000 of them. If we extrapolate this trend further, in 2030, every third person is going to be an Elvis Presley. And I have the suspicion that many of these trend extrapolations are actually done in this way. They're looking at just one parameter. The world that surrounds us is not a linear system with clear cause and effect relations, but a complex dynamic whole where there are many influences acting in a kybernetic way at the same time. So the question is, what is a suitable model for thinking to forecast the future adequately and could serve as a basis for forecasts? If there is no certainty about the future, then we should actually stay away from the wish for secure statements about the future. Any forecast about the future, especially those reaching far into the future, are simply wrong. And for this reason, we have seen that the one future does not exist. The insight has taken ground that we have to think in alternative futures. We have to get rid of the idea of a future that can be forecast, but look at the alternative developments of systems and include them in our thinking. This is something that is considered or called a thinking open to the future, future open thinking. If we are confronted with too much complexities, then instinctively we try to reduce them. The kybernetic approach to this, to deal with complex problem, is actually to absorb complexities. This means that the increase of complexities is actually encountered by in more interlinked thinking to account for these complexities. The linking of these futures leads us to a scenario. What is a scenario? Scenarios are hypothetical views of the future that are based on a combination of factors and assumptions. They actually open up a space for possible developments. They're open to the future. It's no longer tried to make one forecast, but there are several options that are being integrated as images. They are interlinked and they're based on systemic thinking. They actually reflect the various factors in order to keep up the complexity of the situation. Simply put, scenarios are alternative future of complex systems. The concept of thinking in scenarios, the overall concept of thinking in scenarios, is closely linked to strategic thinking of the future, where strategies can be developed in an interlinked fashion. We use here now alternative futures to identifying the benefits and potentials of the future. There are also different scenarios, terms, and definitions. We have different types of scenarios and different methods that can be employed. The main difference is often made with the different methods as to the construction of deductive as opposed to inductive models. Deductive scenarios actually have a theme, a topic that is predetermined in their core. The inductive procedures actually take the various scenarios from alternative sources and combine them by help of key factors. Further, very important distinction for the work with scenarios is the setting, the environment. Environment scenarios also look at parameters that cannot be controlled. They look at what's happening in the scenario and that cannot be influenced by us, and so we have to take these factors into account. On the other hand, strategy scenarios or strategic scenarios are exclusively usually based on ranking parameters and reflect the respective positions, and they call a decision from us. The process of scenario-based development actually is a generic process that is valid in management. The first analysis, internal and external analyses, strategy formulation, and so on are all steps in this. The process of scenario-based strategy development is fundamentally influenced. Unfortunately, the speaker is turning away from the mic occasionally. So actually, this is shown in the internal analysis is then enriched by various fields. How do we get from these scenarios to the strategy? We have two options. So these are the alternatives here, and I will try to see what we can derive from these scenarios. The second step, systemic and more innovative approach, and this is something that we do in our processes, is to describe the scenarios first and then actually describe the strategic scenarios, so that when we develop a strategy, we use this future matrix, and these scenarios are actually considered test grounds, and in this way, the future robust strategy options are found. And of course, one can interlink this also with other elements, but it's not often done. What are the forms of scenario-based strategies do we know? This is on the one hand a focused strategy. A focused strategy, we concentrate on the one reference scenario. The most probable one could be such a scenario, or the most unfavorable one. And here we have the necessity of an observation and early detection of strategy. And early detection, on the other hand, we know the extreme. It's like a beam of robust strategies that actually relates to all strategies. In this area, you have long-term planning and resource scattering. That means that if we look at it in this way, we have a focused strategy that actually is light baggage. You only have one special suitcase with special stuff. You don't have to pack much, but you have to make sure that the right things are in your suitcase, and you have to listen to the weather forecast. And actually, if you haven't packed the right stuff, you may end up having to buy things on the trip. In a future robust strategy, it doesn't matter what the weather is going to be like. We always have the right things with us. We have less to do. We have heavier suitcases and more baggage, and that need to get packed. And in the end, strategy development happens always between the principle of resource scattering and strategic flexibility, the economy of forces. If you strengthen one principle, this weakens the other automatically. This is the way it is. And a scenario can also cannot predict the future. It does not describe the one and only future. Scenarios are models or corridors, as we might call them, to meet the challenges of the futures approximatively. None of the scenarios described is actually going to come about as it was described. A scenario is not based on odds and probability, but consistencies and the lack of contradictions. A scenario is not good if it happens exactly. This is not one of the criteria for its usability. Scenario actually are good if they stimulate the right decisions. Also, it's never objective, but it is group subjective. It reflects the opinions of the makers of the scenario. A scenario is not a decision, but it is an instrument to support decision making, and it's not a strategy, but it is a tool for the development of sustainable strategies. I would like to conclude with this slide and a quote by Charles Darwin, where he said, "It's not the strongest species that will survive, not the most intelligent species that will survive, but that species will survive that will best adapt to the changes of the future." And with this, I'd like to conclude and thank you for your attention, and I'm looking forward to your questions. Just to stay in time, only 3 questions, not more. First question, please use a mic. Please use a microphone. We need this for the translation into English. I'm a little upset. You said we need to think in scenarios. This means that we cannot, this doesn't mean forecasting the future, and as a strategist and officer, if I develop scenarios, I have to know, or at least have some idea about what the future will be like, because I have to know what will the modern war mean. Next step, how do I prepare my armed forces? Then the next step is, what do they need? What weapons, what equipment? And the decisive point, how do I train my group leaders and commanders? Shouldn't I develop scenarios where, subjectivity is okay, where a possible waging of war is contained? This is something that I learned. And the question, of course, linked to that is that we cannot question just everything. Do you get this? Well, by making a scenario, you generate knowledge about the future. You will not be able to predict what the challenges will be in 30 years. This is impossible to say. But what you can do, based on the present, develop some key factors in the system and define them by using certain methods that you can then shape alternatively and look at if these key factors develop in a different ways. You can develop certain aggregates that will be the basis for several scenarios for the future. And this means you are creating knowledge about the future, because in this way we can see in which fields our armed forces will have to act in 20 and 30 years. And then you have the option to develop strategies that are future robust. You develop options, and ideally you do have options, and then you have a test environment, and in this test environment, you will try to select future robust strategies with the abilities that we talk about capacities or core competencies in business. Make sure that these core competencies are included and covered by these scenarios. This is now the contrast of diffuse, and we actually want focused strategies for the reasons that you mentioned, that we as the military and also in the security field in general, it's not restricted to that, we always have to plan in a future robust way. And so I'm going to open up the space with these scenarios for the future and generate a very complex whole that generates knowledge that can be used for orientation in the future. And based on this, I will do the planning for the future using the range, considering the range of challenges and tasks that the military has to cope with. Have I answered your question? Very simple. But then the organizers were actually anticipating your question, and this is why other speakers were invited who will give you answers from their points of view. Because this is a very, very wide range. And this is now the challenge of this conference. How manifold, how broad this range of topics is. This is just one detail from military strategy. We have to look at it from a systems point of view, and this is why we are going to have more speakers. There was another question from the back. There was another question from the back, sir. Okay, Mr. Korkisch. Thank you for this great contribution. Interesting input. Brief comment. You don't need to answer. If all these logical derivations and analysis are made, why is there so little of this in the Austrian security policy? Why do they say EU, OSCE? Why don't they put this on the front page? Is this now what you are saying, what you're doing, not something you want to publish? You don't have to answer. Oh, I'd love to answer this one. I must say, however, that the Austrian security policy was not based on these considerations, but the Austrian defense strategy was actually published and developed in 2011 in a very similar process. And here, of course, we have the selected strategic options in this concept. It's reflected by about 80%, I would say. Of course, in the ends, ways, and means, we have some political compromises that we had to make. We had to adapt a few points, and this is why also the name change occurred. We have a strategic overall line that we developed, and along these developed strategy option that we had worked out, it was then, it went through a political process then in the ministry first, and then it had to be adapted and harmonized. The same we find also, it's also the famous strategy option of 2. It is also reflected with all the strategic tasks, and this is something that was not implemented, but that's a totally different topic. Yes. I have to say, I cannot really say much about the OGSS, but the policy is based on this F2, which was handed over to the Department of Military Strategy, and within the planning process, it was actually then further developed. we can say that we are at a point right now where we need to do a new evaluation, a reevaluation, and this is scenario monitoring is one of the new tools. It's the process that actually we would then do after the scenarios have been developed. We do the scenario monitoring and controlling. Thank you very much. Thank you. We are taking with us that also the development of scenarios is a task of technology, because somebody with a liberal arts education can't do this. We need scientists, we need facts, we need technology to be able to do this, and there are models, as we have heard, that help us and show us how to do this. And also the Austrian Army is doing this. This brings us to the next speaker.
So the next professor is Mr. Weigand. He's a mechanical engineer, and, well, he's a practitioner. So for many decades he was in charge of technical developments, especially in the area of mechanical engineering, helicopters, etc. He developed different kinds of drives and drive systems, gears. So then he went into applied research, and now he's working at the Technical University of Vienna as a researcher and as a professor to make sure that his practical knowledge can be passed on to future generations. Professor, I would like to ask for your presentation. Thank you very much for the introduction. So let me start with a few introductory statements. I heard from the scenario of Gottlieb Daimler, and I'm wondering whether maybe in Vienna the fiacres that you still have here, these horse-drawn carriages, are still using the same principles. Now, as to myself, your interpreter has a request. Could you please tell the chairman to switch off his microphone, because we have a really bad sound quality if both microphones are open. Please remind the chairman to switch off his microphone, otherwise we have really bad sound quality. Is anybody listening to the English interpretation? Please tell the chairman to switch off his microphone. Thank you. Yeah. Thank you. Thank you. That's very helpful. That's much better. Thank you. So the main gearbox of the Christophorus helicopter, the part that is between the motor and the helicopter, the rotors, and ZF Aeronautical Engineering is also in charge of all the dynamic systems, the shafts and gearboxes of all helicopters of the German Federal Army, the Bundeswehr. So I worked primarily in the civilian part, but then also in the military part, the helicopter 105. Well, there are a lot of military as well as civilian aspects. Now, I would like to briefly talk about the technical perspective, and I would like to talk about what's happening in the area of helicopters. So there are new rotary wing aircraft, rotorcraft that have a bearing on what I'm going to present here. So let me present what we are dealing with here. And what are we doing in the area of teaching? So we're in charge of the basic training of students in the area of mechanical engineering elements. So every year we have about 350 to 400 students who take up this course of study. And apart from this basic machine element course, we also offer another course. In light of my prior work in the industry, we have created a curriculum on the subject of aeronautics drives or powertrains. So we have lectures, practical exercises, and seminars. I think this is quite unique, this course of studies, because we also focus on some of the specificities of this field. So if you develop a product in the area of the aerospace industry, it is not the same as for other products. You are subject to relatively complex requirements in terms of approvals and homologation, and this is the basis of what we do there. So when you develop a product in this field, the requirements stipulate that you need to do tests and experiments on the ground before you're allowed to fly. So hundreds of hours of clearly specified tests and experiments need to be conducted. The drives of helicopters are the only components that cannot fail. They must not fail. So you can safely land if something fails, but the rotors need to be rotating, the main rotor and also the rear rotor. So this is why we have quite specific requirements here, because if anything were to happen to the main or the tail rotor, the entire helicopter might crash. This is about 10 minutes from here at the Getreidemarkt location. This is our institute with a lab. And here you can see an experiment with the Eurocopter, or Airbus helicopters as they're called today. So these were experiments where it was about analyzing the behavior of the ball wheels at the main shaft that links the main gear and the gear of the rear, of the tail rotor. So this is our largest test rig that we operate. The tail rotor powertrain of a turbine-driven helicopter is simulated. The turbine characteristics can be shown by a machine. So we take this powertrain of the tail rotor, put it onto a test rig, we drive it through shafts and a motor, and through the generator we generate movement, and this gives us an impression in this configuration where we'd have maybe a performance of 300 kilowatt, and this is a lot more than what you would need for the Christophorus helicopter. Now if we were to use a mechanical system, we would have up to 2 megawatt output. Now this is the test rig. So here you can see the powertrain machine, the individual tested components are here. That's the tail rotor of the 105 helicopter. So here a single stage conical gears. So these conical wheels are the most complicated parts, and this is where we do our fundamental studies. But the infrastructure, so we have the documentation and calibration. So here we can't only do development testing, but we can also do the homologation and type testing. So this is to symbolize the entire thing. This is important for teaching and research. So that's the civilian regulations that need to be respected, that are needed to produce helicopters and to document the airworthiness of these helicopters. So that, of course, needs to be respected. And what this means for research is that we're only doing things where we can see that this will have a chance to be used for real-life products. And that is an aspect that we're going to increasingly focus on. I have my focus on powertrains of helicopters, and the Federal Ministry of Transport, Innovation and Technology has promised a professorship that will be dealing at the system level with these aircraft. So the system design, but also the scientific background for all the companies that are active in the aircraft industry. Now, we're not sitting in the ivory tower alone, and this slide is supposed to demonstrate this. So over the past few years, together with the Zirkler company in Joyce in Burgenland, the entire mechanical powertrain, all the gears and the connecting shafts, the tail rotor gear and the main gear for the civilian helicopter Kamov KA-62, 6.5 tons weight, up to 17 passengers, primarily used for offshore applications in order to fly to oil platforms. So we developed this. The first flight of this helicopter took place 2 years ago. We're now in the continued testing, and this is in Joyce in Burgenland. So that's one of the biggest helicopter test rigs in Europe, and one of the few in the world that has coaxial rotors testing capabilities. So that's an ideal example of the good cooperation between university and industry. Now, of course, we can try to differentiate between the optimization of the existing technical solutions and new strategic approaches in technology. So this had been a first project between 2011 and 2014. A nationally subsidized project optimized helicopter gears made in Austria. OHA is wow in English. Together with Schiebel and Pankel, 2 Austrian companies, we tried and tested everything and projected it onto existing gearboxes in order to develop this further, because a lot of things that are tried and tested in the automotive industry are not used for aircraft because the qualification requirements are too high. We have to prove, for example, for such a gearbox that even if all the oil is lost in the gearbox can continue to operate for 30 minutes under certain conditions. Now, if you were to project this onto your car, you will certainly not be able to drive your car without the oil, without the engine oil. Then there's the Schiebel camcopter that I'm sure that you're familiar with, where we tried to use this, and we also realized a test rig in our lab. Now, what's happening at the technical level? What are some of the technical approaches? So like I said, we have the existing technological solutions that are improved, but there's also fundamentally new approaches.
And of course, the question is, how can an existing helicopter be improved? The basis would be H-135. This is the Christophorus helicopter on this basis. We developed a new rotor head that is more efficient, with a better performance, a new drive systems with more performance, more power, and making less noise. And part of this is also that a new rotor blade was being developed. Here the design with technical advantages. This is just one example. So what is new here? In our world, there's always the question that arises really fast. Is all electric, more electric? These approaches do exist. But there are 2 points we need to fight again, and that is weight on the one hand and the questions of registration. And this is, of course, where we have to take these points into account. Is this feasible? Can this be actually implemented as a real-world project? This project failed. This rotor blade adjustment was operated hydraulically with the Royal Navy. They tried it with a helicopter type A1, and it was done electrically, and within the registration it became heavier and heavier and more expensive, and in the end it actually failed in the registration approval process. So it's not so much the mechanics, but it was the electrical side and the software. If the software doesn't work, the whole thing is not going to work. So where we are also doing a lot of work is the Forum of Aviation Research, where all countries just actually send one research institute as a representative. We are taking part with the vertical lift project, and that means how can these rotorcraft be used as load bearing for enhanced load bearing functions. And this is something that was in 1957. There was a technical solution with 40 passengers and 190 miles per hour between London Heathrow and London Battersea. It was actually planned to transport passengers this way. Their role today is rather limited, apart from taxing, and we are far away from actually having such a solution available. Therefore, the initiative with 15 nations, we have now a project in order to derive future concepts in continental and European research efforts. Here another example from 2002 to 2007. Those was a European research product that was actually one type of rotorcraft that would have been able to land and take off like a plane. And we have now the development of new rotorcraft. We have the cross curator that has a higher forward velocity as a strong point. A further alternative with Bell-Bella, both have had their first flight so far. They open up totally new options for the military and the operations. This is the most complex of all, by the way, here. In Europe, we see approaches for Airbus helicopters with the so-called Razor, with more forward velocity, and Leonardo. In Italy is another project. They are propagating rather the tilt rotor blades. They are European efforts here to also develop this further. And what we can see is that the classical configurations of helicopters are and more being softened up and changed and adapted to tilt. To become tilt versions of the rotorcraft. The Helicopter Society, one of the largest scientific bodies in this field, is going to get a new name. Vertical lift is going to be, and the company Bell Helicopters don't call themselves helicopters anymore, but only Bell, because they say that this is now too limiting a word. What we see also on the drive side is that the rotor velocity is being changed. This can be done via the turbines and and here we have an example of an SUV that has a double gearbox with 2 gears. It can only be operated now because it doesn't need a registration, because we will talk about the gearbox mechanism in the future. Carrel, this is a company. They have built the Hummingbird aerotrain with 2 gears. And what this means is here we have the comparison on the Boeing rotorcraft 737 with a vertical lift. That's going to get integrated here. There are quite some endeavors in this field to develop some of this further. There also is a strategic aspect involved here, and that is the interplay of manned and unmanned spacecraft. Airbus helicopters together with the Schiebel company, where we were flying a mission together, and from the Calgary UAV was being operated, and this is now something that is actually cannot be done for manned helicopters. What we are working on with a higher forward lift speed, also with the tilt rotors in helicopters. We have the VariSpeed product. It's a transnational project with TU Munich and the company Circle. I already said that the turbines can only be actually done in a steady way if we have a rotor variable, because unfortunately we never got any preparation material from the speaker, so it's a little difficult to follow here. And the only solution that remains is that we need a rotor for a variable rotor count, and this is difficult, but we also need a gearbox with a constant that is a variable transmission, and this is something that is interesting, and there are two tasks. One is, this is a great performance. Here we need to vary. This is one task. And the other one is that all of this should become a realistic product for the implementation. But we are oriented in this project on the Black Hawk helicopter. We're not only focused on the Austrian Black Hawks. This is a helicopter that has over 13,000 units. It's one of the most used helicopters worldwide, and is actually technically pretty advanced. We are working on this. We hope we'll get the funding so that we can also implement this and try this out. With Circla and yours to actually also get approval, and a lot of things. To sum up, a lot of things are happening in this field, especially on the vertical lift front, and this is our motivation. Almost all helicopter manufacturers have a project that's going in that direction, and everybody is sort of developing a product along these lines, but it's a little bit like developing a drug, hoping that the corresponding disease does exist. And this is why we have started an international initiative to harmonize and these various attempts. We hope that we will be successful, and I have been very thankful that I'm grateful that I've been able to present this to you. We got a lot of support. It's not far from here. It's at the TU site, about 10-minute walk from here. Thank you.
Vielen herzlichen Dank, Herr Professor Weingarten.
Thank you very much, Professor Weingarten, for this insight into the development of technologies. Because what we can derive from this is future scenarios in terms of what's technically feasible. I think this leads to certain problems because this requires mutual understanding of the various disciplines. And things aren't really going the way I had thought they would, because the engineers, they live in their bubble, they live in their own world, and they're trying to do the best and optimize whatever they're working with, whether this makes sense, whether this is future-oriented, whether this is actually needed, and what will the impact be of such a technological development. Well, these are questions that need to be addressed by military strategists. And this is where the military comes in. So the military needs to understand that they are interlocutors for the engineers. So I believe that This has been an excellent example to demonstrate how things are working at the practical level, and of course, as an Austrian, I'm proud of that these developments are taking place here in Austria. Because hardly anybody knows the Ritter company. Well, actually, that was a very dangerous statement, namely that you could organize such a field trip where we could see these things firsthand. I'm sure that this would be highly interesting, and I will take you up on that proposal. Okay, so any comments? I have a question. As far as I know, a technical project will have a duration of 10 to 12 years, from the idea to the implementation. Now, what results from that is that, well, I didn't know that Austria was really predestined for this field, but my question is the following. On the military level and at the economic level, how do you cooperate with other countries here in Europe, or do you also have corporations and joint ventures with other countries? Because I imagine that, based on my past, that the Russians have completely different helicopter developments than the rest of Europe. So you didn't even show some of these projects. The coaxial rotors, yes. So from my perspective, especially as far as this future-oriented scenario is concerned, where we don't know who will have to go where and how, we have to be able to deploy as quickly as possible, within hours or days. And of course we need fast mobile forces and units that can be sort of folded up and redeployed elsewhere very quickly. I think we might run into big problems if you do research and then all of a sudden a new project comes up somewhere else. Okay, I will interrupt here. This is very impolite, but we are very much behind our schedule, and to give the other speakers a chance to give us their presentation, I would like to ask my colleague to give us her presentation. Ms. Hinterstoisser.
Professor Hinterstoisser is from the University of Life Sciences, but studied at the University of Vienna, and as I mentioned before, actually also studied philosophy. So she has the understanding of the basic principles, and we're looking forward to your talk. Thank you. Ladies and gentlemen, I will try to be brief, and actually I could do a lot of talking about the possibilities of developments in infrared spectroscopy, but I've decided to skip that and rather talk about it in a more general way. As I have worked for 9 years in the management of the university as vice director for teaching and international affairs. When I saw the title Narrative, Hybridity and Resilience, Cyber, I asked myself, are these buzzwords that are trying to actually just cover up what's really happening, so that we are in a fog of ignorance, in a mist of ignorance? Maybe in earlier times we would have said that you don't see the wood for all the trees. In this fog, in this insecurity vis-a-vis the future, we are trying to find our way, and we're groping ahead. And of course, it always depends how we define. We try to get through a thicket of trees, try to orientate ourselves, and we try to develop a strategy that makes it possible for us to achieve aims. Very often these aims are very short-term, and very often they're too short-term to be really reached. And the sustainability idea, and I know you can't hear this word any longer, but it is a very important element for the future. And this idea of sustainability means that it is important to go long term, to be courageous, and to think in larger dimensions, not just go for short term thinking and quick solutions to achieve apparent successes. Our acting is more and more determined and dominated by quick fixes, by a profit-orientedness, and by a certain egotism. New technologies are flooding over us like one tsunami after the other. And this is something that's happened at an increasing pace, as we have already seen at this conference in many examples. The question that arises also is what happens to people. Here, resilience is being called for, and it should be expressed in values and attitudes, missions, in an era culture, by critically questioning something that some of us may have lost, and is also something that should be more in the foreground at universities. Nevertheless, all of these thoughts are getting us to a strategy of finding a way through the mist of ignorance. We are discussing at the universities about ethics and science, about responsibility of the instructors. We talk about role models and ask ourselves, what have we really learned as human beings from the past for the future? And the next generation, especially the natural sciences and technologies, are a very tempting springboard for a feasibility thinking that's all-encompassing. Anything is feasible. Everything that can be thought can be made. This is something that's also promoted in the advertising by some companies. With a certain arrogance, we believe that everything can be controlled and determined by us. Many things are possible. Maybe too many things are possible. Self-restraint, ethical principles, and sustainability are certainly just buzzwords in some cases. And here I'm coming back to the mission statement of the University of Life Sciences. We try to integrate various sciences, technology, also the social sciences, and the liberal arts also, in order to guarantee the sustainability and the sustainable use of resources, and in order to be plan ahead, to deal with problems, to develop solutions for the future by developing ideas, by a large number of scenarios that we can offer in order to reach a certain flexibility. And this way of working and working out solutions in an international setting, we work in cooperations globally with other universities and in an interdisciplinary field. And this actually becomes more and more important. The interplay of international scientists together at a high level should actually lead to a creative way of solving problems and to be able to solve problems that we're faced with. We have heard about systemic thinking, and I can proudly say that at the University of Life Sciences, the systemic thinking has been integrated in 1872, since the year of its foundation. We were heavily focused on agricultural scientists. Without systemic thinking, agriculture would not make sense, could not be successful at all. And if you take a look at the programs we offer at our universities, the study programs that are being offered, the transdisciplinarity, the multidisciplinarity is very much in the foreground indeed. Cultural technologies, forestries are being integrated. I cannot talk about this, but this is certainly very much in the foreground, and a true interplay of the various disciplines and sciences. Multidisciplinarity are the buzzwords of today and of the future, and I would like to plead for also general education that seems to be a little lost today and neglected, let's say, something that was also underlined by the Federal Minister this morning, how important a general education is for the international understanding, for being able to communicate with others, to be talking to others, to be able to listen to others. All of this is something that is promoted and trained by general education, especially in engineering and the technological sciences. We have to be careful that we don't have too much of a specialist focus, and this is certainly important to integrate other disciplines and to talk to each other, to be able to talk to each other. And this is one of our strategies at the university. Ethical aspects, ecological aspects need to be taken into account. The various disciplines and how they interact and communicate with each other is important for the future. We're easily hiding our deficiencies and deficits by new terms that actually are largely incomprehensible. What matters is to communicate with people. This has already been pointed out today. And I would like to, again, come back to what the Federal Minister said. It is important to communicate, to talk, but also to listen to them so that we can take them on a journey because we pick them up where they really are standing with their knowledge. And all of this is something that is so important and should be a decisive factor to formulate our actions. My personal motive, and with this I would like to conclude, what I have to say is so important that I would like to say it with simple words so that many people can understand what I'm saying. Thank you. Thank you so much for this input. But if I look at my watch, we are already in the coffee break. So for this reason, then we have a technical problem. You can't have a coffee break and do small talk and listen to the next speaker. My proposal, therefore, is that you actually file out individually, come back in. Otherwise, I don't see a chance to finish by the time. Or we just all wait, and the discussion we're going to move to a later time because it's about, we will have a panel where we will have the summary and maybe we can have a quick discussion then. Thank you very much. Very interesting, and here too, a very, very different approach, and because the biosciences or life sciences, as they're called, are promoting, are not so well known in the public. We are actually often reducing it to a linear function, but it's very complex, and with all this complexity, we need time. Thank you so much for all the information.
Now I would like to ask the next speaker to take the floor. That's Professor Thomas Görnitz. Professor Görnitz will be presenting a very fundamental thesis. And I'm looking forward to his presentation. Thank you very much. Thank you for the invitation. So I think this is a wonderful presentation. I'll try to be fast. So as the previous speaker already said, it's really about interdisciplinary work. If you want to come to the nuts and bolts, so it's about laying the foundation. It's about strategic thinking to be combined with scientific foundations. So our meeting and the previous conference showed that, of course, modern science is very important, especially when it comes to strategy and military. So the cultural and psychological bases are important. Operating modern technology doesn't require any further knowledge. So switch on the computer without knowing how it works, you drive your car without knowing what happens in the gearbox. But of course it is clear that the higher up you are at the levels of leadership, the more essential it is to know about the material and to have some basic knowledge also about the structure of man. Now, you may wonder why talk about quantum theory. Science wants to understand the foundation of reality. So it's about reality, not about some simulations. The simulation of a helicopter is not a helicopter. So if you want to aim with your gun and simulate an opponent, well, this is something entirely different than a real live opponent. So it's about describing nature precisely. And this precise description of nature requires a radical rethinking. So we should move away from this one-sided unilateral approach that is often taken as being absolute. So quantum theory has enabled technological developments that had been inconceivable even when I was a student, not even at the time of my grandmother. So it's of course nuclear weapons, and of course this has something to do with quantum theory. And if you have enough ignorance about physics, then that makes it easier to take irrational decisions about, for example, the use of very small nuclear weapons or whatever. So we heard a lot about virtual objects in the previous conference too. So quantum theory shows that the virtual object produces real effects. And of course we know that. Our ideas, our opinions influence our action. But that already happens in nature, in inanimate nature. Phonons, that's virtual particles. They can't fly around freely. But in electronics, these phonon exist as if they were real. And they react with real electrons like other particles react with each other outside of the atom. So electronics is based on modern physics, understanding the behavior of these virtual objects. So molecules, well, cell phones would be incomprehensible if physicists hadn't learned to understand it. The modern sensors, of course, when you turn your cell phone around, the picture turns around. So there are sensors installed in your cell phones that react to gravity. But there's, of course, also sensors that react to, chemical substances, artificial noses, we call them. It's extremely important so that you can identify chemical agents, not because your neighbor is turning blue, but because, you feel it in your cell phone and that tells you to put on your gas mask. I'm not a member of the military, but as a layman, if you see how a tank is moving forward and the cannon keeps being focused on the target even though it's going up and down, well, that only works if you have sensors that can capture the target no matter how, in which direction the tank is moving. Then there's autonomous weapons, laser beams. In my youth, this was still science fiction. Think GPS. GPS means that the results of the general theory of relativity and of quantum theory are used together in one system. So the GPS satellites that are circling planet Earth have to be described in such precision that the deviation, that the general theory of relativity and Newton's theory of gravity results, well, this needs to be compensated. And this needs to contain atomic clocks so that they only differ by a second every few billion years. And only by combining the two can we have such precise location systems and positioning systems. And that was the big surprise in the first Iraqi war. The Iraqis knew that in the desert nobody would be able to get through, but they didn't know that the tanks were equipped with GPS. They knew exactly where they were and where they had to go. And we have heard a lot about the internet. What quantum theory shows is that there is a possibility to have an internet that cannot be eavesdropped. So the decisive tests have been done here in Vienna. And for me as a German, it is interesting to see that the Chinese are well financing and looking after this project, because as we've heard repeatedly, the Chinese are highly interested in making sure that the NSA cannot eavesdrop on them. So in a few years, the Chinese are going to have an internet that nobody can wiretap. So it's impossible. Well, of course, you can think about this. So it's important to know about science and how it all relates. Now, we heard a lot about cyber. There's a lot of empty talk. But all the electronic efficiency that exists today is all based on classical logic. That means, on the one hand, that these machines are capable of establishing and identifying correlations in large amounts of data. This is really important because when it comes to identifying structures in such chaotic systems, we're not really that good at that. But finding this correlation, well, often that has nothing to do with causality. So there's this nice example of a study where there's a positive correlation that is well established between the appearance of storks in southern Sweden and the increase of babies being born there. But nobody would think that there's a causal connection. So artificial intelligence, well, doesn't have any creativity. So everything that is working based on classical logic cannot be creative. Creativity cannot be reconciled with traditional logic. Traditional logics, well, that's mathematical structures, algorithms. And these algorithms, well, put out what you put in a slightly different order. But creativity is something that gives meaning to new things. Traditional logics cannot really lead to really new things. So these so-called self-learning systems are also misleading. You know that computers can be programmed, and then there's a second type. Those are called neural networks. That sounds nice. Basically, it's like the brain, same structure. A neural network is like a large assembly of switches, and these can influence each other. And these neural networks are then trained. That is to say, you provide them with a certain data set, and then you change the neural network until the data entered coincides with the desired end product. And then it is hoped that when new data is entered next time, this is done in the desired way. But of course, we don't know that it is going to do that. These self-learning systems differ from the past systems is that this training process is not stopped, but that the systems are supposed to keep learning and change themselves, but in a way that nobody, well, has any control over. So this Uber car, for example, there was this woman who crossed the road, and they thought it was a waste bin, and the woman was run over. So we need to know about this when it comes to, well, automatic weapons that kill without any individuals being involved. So there's the usual quanta, protons, neutrons, electrons, neutrinos. Well, they have a very small mass. Photons are objects that always move with the speed of light. And then there's something else. There's structural quanta. Those are quanta that behave in certain situations as if they were particles, but they never exist as particles, such as the quarks, gluons, but also phonons. And electronics, of course, needs to understand those. So this is the basis of electronics. Now, a lot is said about quantum theory, that it's hard to understand. Of course, it's a difficult mathematical theory, so you need 2 or 3 semesters of maths in order to understand the basics of quantum theory after 1 semester. But if you understand the mathematics, and this is what I reproach my physics colleagues, then the basic principles can be easily explained. So it is much closer to our day-to-day experience than classical physics. Our human behavior is influenced by our options that we are hoping for or afraid of. So it's not only facts that influence our behavior, but also what we expect to happen. And the same applies to inanimate nature. The changing of options and possibilities changes the behavior of quantum objects. And we know that relationships are important. If you have a relationship or one that failed, well, no, this is the case. And if you have kids, you know it too. So a relationship is more than the sum of its parts. And the whole is more than the sum of its parts. That's a basic principle of quantum theory, whereas classical physics insists that there are separate objects and forces between them. So, atomism or quantum theory. So, in quantum theory, energy, E, correlates with the extension of the wavelength. So if E gets bigger, lambda gets smaller. So the smaller, the more energy. So the idea of atoms is the smaller, the simpler. But quantum theory says that the smaller, the more energy. And if you were to summarize this, the conclusion of the atomistic concept together with quantum theory would be the more, the easier, the more, the simpler. And that's not plausible. So this path toward ever smaller units ends at atoms. And of course, the body is more complex than an organ, and the organ is more complex than the cells. And the cells are more complicated than the molecules, and the molecules are more complicated than the atoms. But that's where it ends in terms of getting smaller and simpler. Because the further down you get, the more complex theories become. And, well, if we had time, we could really go into some detail, but this is a dead end, and this is sheer and pure mathematics and not physics anymore. And this may come as a surprise to you, but the smallest thing that can be conceived in quantum theory is a quantum bit. A bit is something simple. So a quantum bit, of course, is the most extensive structure you can conceive of. So a very simple mathematical structure. It's a bit, it's yes or no, in two-dimensional space. And what's important is if we go into physics, and we notice this from the lectures here, meaning is always subjective. So meaning can never be objective. In the best case, it is intersubjective. Now, physics is aiming at the objective, so it needs to move away from meaning. So that's the bit. And if you talk about the different possibilities, you get a two-dimensional space, an abstract picture of quantum information. So that's the most abstract thing you can have, mathematically speaking. But since information always is correlated with meaning, we had to create a new word. It's protyposis. So that is a quantum information devoid of meaning or free of meaning. And mathematics has demonstrated how quantum information can be used to build up energy or matter. So just imagine you're supposed to find a document, and all you know is it's somewhere in Europe. And you don't stand a chance of finding it. But if you have a lot of information, not only the country, the city, the house number, the apartment, whatever, then you're capable of localizing this information. So all of a sudden, this madness of quantum energy, a lot of energy gets smaller. So if you say a lot of information allows you to narrow down. But this requires a process of rethinking. So if you want to move away from these blinkers of small atoms, well, you don't have a chance of opening up to that reality. And we have heard that that often leads to problems in understanding. But if you focus on the basics of physics, it becomes possible to explain life. So life is a thermodynamically unstable system which is self-stabilized by internal information processing. And the point is that in all living beings, there is no fundamental distinction between hard and software. Every thinking process will change your brain. That is to say, we can no longer differentiate between hard and software, and that makes it possible to do something, for the brain to do something that current computers can't do. We also heard that meaning has different levels. The first level in evolution is that meaning is, the probability of survival. So all beings that don't care about survival will fall out of evolution. Now, if living beings go for the sexual procreation road, there's a second level. Meaning can be important for your children without really focusing on your own meaning. So if you use a language-based culture, there's a third level. So we heard that some time ago in Europe there were still duels because the honor was, violated. Somebody's honor was, insulted. So that's the biological hardware and software is turned into uniware. And of course, if the foundation of reality is something that is more closely related to our ideas than to our bodies, it becomes clear that now we have also an approach to a scientific understanding of consciousness, not of the mind, but of consciousness. Now, on this basis, and with the help of new physics, we can now understand and explain why our thoughts act on our bodies, and not only the other way around. So consciousness is a special form of protyposis. It's quantum information that experiences itself and that recognizes itself. And consciousness always opens up the possibility of freedom. We hope sincerely that people will not endow artificial systems with consciousness, because these will do what they want and not what we want them to do. So that's important. Of course, I can send you the remainder of my slides. Mr. Peschel is putting pressure on me to make sure that I speed up, but I had to say those things. So we can make it clear that the way from the body all the way to reflected consciousness and back from consciousness all the way down to the physical level. So those are the mathematical and physical results that have been published in English-speaking literature, and of course you can also find it in our proceedings, 800 pages. Anyway, so you can read up on all of that, and thank you very much for your patience. Now you understand why so many people are afraid of studying mathematics and engineering. But these are the foundations. And now you also understand why the central final leaving exams, high school leaving exams and maths, well, there were so many failures because our children were taught by teachers who never learned how to really teach. They just learn by heart and they just teach recipes, and that's not enough. That is the new approach that we need, and it is about time that such a subject be introduced here at the strategy conference. So it is so important to learn about the basics, the foundations, and then maybe also derive some practical and technical consequences. That's the only way it works. And now it's a real disaster. Looking at my clock, at my watch, actually we are already behind schedule. Okay, so I would like to ask the last speaker to briefly take the floor, Professor Mang. He is the president of the Academy of Sciences. He wrote 23 books, more than 500 essays. He holds 6 honorary doctorates. He's a member of 20 academies, etc. So much by way of introduction. Please do take the floor.
Thank you for this kind introduction, generals, ladies and gentlemen. All I have left of my manuscript is the first sentence, which is a definition of the term strategy. It, quote, exactly planning one's own actions, serving the purpose of achieving a military, psychological, political aim. If this was the definition, so my life is actually without any strategy. But that this is true with states like China, or whether it's really so different, is something that I leave to the experts. What I studied building engineering, mechanical engineering. I'm an expert in static, computer-related dynamic calculation of building constructions. The main aim in my work is the forecasting of the load bearability. And when you're driving a tunnel, for example, close to St. Stephen's Cathedral, because a new subway line is being built, so you want to do like 4 to 5 meters a day. What is it going to look like the next evening? Is St. Stephen's Cathedral endangered, in peril? Or if you are in a different area, is the soil hard enough? Do we have to need to place cores in to stabilize the soil? And within certain limits, when the data are showing that the soil is good enough, a construction site will look different. And it's again different if we look at it in the lab. Because in the lab we can say, tomorrow I have planned everything, we will be able to take 6 meters, so much on the forecastability. It's very different when you evaluate damage that has occurred, might have tears and cracks. And then, of course, you have to look back and see what happened, what was influencing the construction, what were the material properties like at the beginning. And this is, of course, a big job with buildings that were built several hundred years ago, with various earthquakes that we've had. This is a big question indeed. My area, this is something that I have explained briefly. It's about calculating finite elements. We talked about mathematics. In mathematics, there is a differentiation of integral and differential calculus. If we look at this tower out there, the flag towers, there are many, many small parts that it consists of. And all these small parts need to be integrated, but then you have to actually align the result to the environmental factors. And this is a very difficult problem. How did I get there? In the late 60s, I prepared for the final exams at the university, and I was using a Georgian method, a Russian method, which was really a Georgian method. And when I was preparing for this exam, I read that there was a method in the US, finite elements, that can actually take care of everything. I was intrigued. And I was asking myself, why was I working on the other approaches if there is something better? But a very important strategy in my life was my wife, who was working with UNIDO, who actually said, take a look, make sure you can go to the US. And this is what I did. And so I had my first military connection there. Air Force had a lot of money at that time, and they supported building faculties. And they proposed to me to do a second PhD on the rapid calculation of fields in the Vietnam War. This was setting up platforms that could be set up in a quick way. And I'm not going to talk about the details. I acquired the knowledge of finite elements in this way, and when I was done, the Vietnam War was fortunately over. These shelters that were built with this method actually are still being used today in Canada to store grain. And when I handed in my work, this was the day when Nixon resigned, ladies and gentlemen, when I returned to Vienna, I was very fortunate. The military was again involved because in Vienna nobody was doing this. In Vienna, I was far removed from actually getting into the career of a professor, but I was starting to do a lecture, and I hadn't really done my military service yet. And I was able then to make an agreement with the military that if I was going to join the military, I could actually do my lecture in a block format, which is what I did. So the next step then, and this again has a military connection and deals with finite elements, was at my time in Texas. I got to know, I wrote to a famous American professor in a very polite way. I was pointing out that there might have been a mistake in his dissertation, and to my surprise, he said, why don't you join me and come here? So I went to Texas, and I joined this famous professor, and I was able to get a scholarship via the Academy of Sciences. This was the first connection with the Academy of Sciences. And in Texas, again, I was very fortunate to be able to do basic research and to work on the calculation of hyperbolic cooling towers. At that time, they were gaining significance in the construction of nuclear power plants. If they collapse, this is a collapse of stability. There was the phenomenon of a bridge that was collapsing. Some of you may remember that. And it wasn't quite clear at that time. And so we were able to answer this question again in a clear way. And there were still many discussions. And at that time, in the development of software that was actually answering the question in a clear way, we were pretty far ahead. I would like to, I don't want to turn this into an autobiography, but we have seen that, we saw then that my activities actually shifted to the east, to China. They were looking for an expert in the field of computer statics, and a Russian had been proposed, who was refused, turned down by the Chinese, and so they wanted somebody from Austria, and so I was actually asked by my professor, and I took this opportunity again in 1981. Then I actually went to China and have had close relations with China since then. And this brings me to the second part of our talk. I was then in China for 3 months, and I was one of the first in my field who was working at the university at a mechanical engineering department focused on heavy industry, and in Nanjiao, which is the capital of one of the poorest provinces, but the cradle of all Chinese history, they say. And I actually worked at a Russian center where I was in charge of 2 tasks. One task was teaching numerical mechanics. These were the first lectures in China, and the students were very tired, or maybe they had deficiency, because I don't think my lectures were that boring. But the nutrition was not very good at that time. In addition, there were big changes in the climate, abrupt drop after hot summer days to very cool days in October in China. There is central heating. That means that if they start heating in Beijing on a certain day, they start in 2 weeks later in other cities. And so depends where you live. If you live farther south, there's no heating even if it gets cold. So what was my task there? I was supporting the institute because they were applying for a mainframe computer with the World Bank. And the second task was to teach finite elements. Ladies and gentlemen, this was another China that you may know today. This was a China with people who were wearing Maya suits, and it was a country where the only means of transportation were bicycles without any lights. I got to know it in October 81, where on a truck at that time, people were being transported, and behind them something like burning poles and they said, this is the sins of the people who are being brought to the execution site. But these were people who needed to get purified from their sins. And based on all this, developed a close cooperation with China, developed the first conference in the field of finite elements in the old Shanghai Hotel, and later a close cooperation with the China Aeronautics Establishment. And since 2005, close cooperation with the Tomsk University in Shanghai, one of the best building faculties in the country, 1.3 billion people, just as a footnote. At first, there were many people who had suffered during the Cultural Revolution. I tried to help some of them, and this was only possible at the beginning by inviting them, and they were always accompanied by one party member when they were traveling. Since 2005, there's a close cooperation with this university. There are joint research projects, and one is called Bridging the Gap. This means, well, several things. One meaning is that it was a bridge that was constructed and finished last year. The bridge linking Hong Kong to Macau, 135 kilometers long, interrupted by a 5.6 kilometer tunnel, where there are actually supports that extend down into the sea. The South China Sea is very shallow at this point. The bridge parts are actually produced on islands nearby, are sealed, and then taken to the site on floating bridges and fixed into the soil. You can imagine that this is linked to a number of difficult mechanical problems. Life expectancy of the bridge is estimated at 120 years. It is a little lighter to forecast something like this than saying like what's going to happen tomorrow in some fields. This cooperation involved a number of Chinese students who then came to Vienna, and I got a Chinese professorship that obliged me to spend some time every year in China. And what can you see there? You see strong willpower in all areas, also militarity, to reach the top with all the politeness and friendliness. This is something that you cannot do without a certain brutality, because the power of the current president is incredible. What's interesting, though, is that in all the news, the president is mentioned, is quoted, President of China, and in addition, they say the chairman of the Communist Party, and this is important for the military, and the commander-in-chief, which means the head of the military commission, as they say. The military commission plays a large role, and this is what's very important. The project of the Silk Road is very important in China. The Silk Road is, of course, a historical term that downplays what this was really about. It's a show of force. It stands for all the interests that China has. This brings me to the end. I have told you about my own life and my connections to China, and when I take a look at this, I see there was very little strategy. On the other hand, I know that strategy is important. Think of applications submitted for research grants, for example. If you don't do it well, you will not get the funding. And this is a reason for rejection very often. I personally tend to reject things if the strategy is too well described, because then I have some doubts as to the novelty aspect of this work. But there is one point I would like to add. And this shows also the basic tenor here in my field. My field is characterized by the demand of very good, even if incomplete, very good forecastability. Thank you very much.